Hey, welcome. Today we're going to be writing fractions as decimals using long division and then classifying them as terminating or repeating. So could you please open fractions to decimals using long division notes in your assignment, and remember, my expectation is while you're watching this video you are taking notes. If it is easier for you, please write on paper instead of this. And then here, if you have to refer back to, this is like a quick and easy how to convert to a decimal. So this is what we're going to be talking about today. But before we get there, I have a couple of other things to show you. Alright, first I want us to explore, can all rational numbers be written as decimals? Can all rational numbers be written as decimals? Next year you're going to have to talk about rational versus irrational, but right now we're just exploring, can they all be written as decimals? So first, let's talk about the way we did it in the last lesson. Can we find the decimal form of 1/6 by writing it as an equivalent fraction with only factors of 2 and 5 in the denominator? So let's take this apart. 6 can be written as 2 times 3. Well, right now we know that 2 times 3 is not, there's nothing we can do to get rid of that 3 in the denominator because the numerator does not have a 3 to cancel it out. So we cannot get to a power of 10. So it cannot be written the way we were writing decimals the last time. So we're going to have to come up with a new way. And we're going to use this idea right here. A fraction is interpreted is just the numerator divided by its denominator. Remember, this line right here, this fraction bar, indicates division. Matter of fact, the further you get in school, this is the only division symbol you will use. You won't use the one that we're used to like this. You will only use the fraction bar. So we're going to think about it as a fraction. The fraction bar is division. So now, and as I said, you can't use your calculator normally, but I want you to use your calculator. So stop the video and use your calculator to explore various quotients, that means division, of integers 1 through 11. For example, 1/11. Do that division, 1 divided by 11, and what is that? What is that decimal? Or 1/2. What is that decimal? Or 2/3. So only using integers 1 through 11. Write down a bunch of them. See, so take 3 or 4 minutes and do as many division problems as you can, but make sure you're naming the fraction, like 1/2. I know this one off the top of my head. If I put 1 divided by 2 in the calculator, I come up with 0.5. So make sure that you're recording what fraction, so that's indicating your division problem, so you don't have to rewrite it like this. So this is your division problem, and then what decimal did you get with the calculator? Alright, I chose to use numerators of only 1, but I did test out all of the denominators 2 through 11. So, what type of decimals do we see here? Well, I see decimals like this that just end. Here's another one. So I have ending, and remember we learned those were terminating. And then I also see those that repeat, 3, 3, 3, 1, 6, 6, 6, 6, etc., etc. Here's 1/9 that repeats, 1.11111 repeating. Here's a 0.09. This is the only one that looks suspiciously like it doesn't repeat, but look carefully. 0.14285711428, and I guarantee the next two numbers are 5 and 7. So the two types of decimals I see when I am changing fractions to decimals using division are repeating and terminating. And this is going to be important for this unit, but especially important for one that we are doing next year in Course 3. So I want you to think, again, terminating, we know the decimals end. Terminate means to end or to stop. Repeat, it goes on and on and on, and not just in a pattern, but with repeating digits. The digits repeat. So now I want you to take a second, and in the chart below, the numbers or the fractions that you came up with, I want you to categorize them: terminating, repeating. So the terminating ones, like 0.5, which again was 1/2, would go over here, or the 1/3 is going to go over here, like this. So please take a second, and I'll write mine in, but you write yours while I pause this. All right, now, so this is what I have, and I want you to look really carefully at the denominators. Really look carefully and see, what do these have in common? And what do these have in common? Okay, so I could see me saying something like, well, they are either multiples of, because I don't think I have my 1/9 over here. I don't. I missed my 1/9, which was 0.111. So they're either multiples of 3 or prime, where these did not have a 3 or a prime number in other than 5. But if we look even more carefully, I had a 2 as my denominator, a 2 times 2 as a denominator, a 5, a 2 times 2 times 2. So in each case, these fractions only have 2 and or 5 as factors. And I hope you're writing neater than I. Matter of fact, I'm going to pause and rewrite that. All right, here it's written at least a little bit neater. So the denominators only have factors of 2 and or 5 if it's terminating. 2 and or 5. Where if it's repeating, there's at least one factor other than 2 or 5. And that makes sense because we know from going the opposite direction that we have to have, for a denominator, for it to be a decimal, we have to be able to get it in powers of 10. So if it's a decimal that ends, it has to be able to have a power of 10 as the denominator. Where here it's impossible, so they repeat on and on and on. So this is the real learning target according to Common Core for 7th grade, is converting the rational numbers using long division. No calculators at this point. So we have to convert each rational to using our long division. So remember, we are dividing 3 divided by 4, numerator divided by the denominator. So this is the dividend, this is the divisor. So what we're dividing by goes on the outside of the house. What we're dividing into goes on the inside. So 4 doesn't go into 3 any, so we're going to put a 0 and then the decimal. So this was a 6th or 5th grade target, really, so this, I'm hoping, is just a repeat for you, or a review. So here we're going to have to add our 0. 4 goes into 30 7 times, because 7 times 4 is 28, and then we subtract, and then we keep adding zeros until we either find a pattern where it repeats or we can find where it ends. And I know since 4 only has factors of 2 and only has factors of 2 that it is going to end. So I'm going to carry down my 0. 4 goes into 25 times. So negative 3/4 is equivalent to, and this is where you need to be careful, because if I just said negative 3/4 is equivalent to negative 0.75, if I left it like that, this one would be to the left of 0, this one would be to the right. So at this point they're not equivalent, they're not naming the same number, so I need to make sure I include that negative symbol in there. All right, 3/16. So I'm going to put what I'm dividing by on the outside, what I'm dividing into on the inside. I'm going to add my decimal and a 0 right away because I know that 16 goes into 3 0 times. 16 goes into 30 one time. So 1 times 16 is 16, and I'm going to subtract down. Remember, you can borrow if you need to. 16 goes into 14 0 times, so we have to add our 0. And now 16 goes into 140. So this is where you might have to write off to the side 16 times what, and make that good first guess. I also want to have a feeling, have an idea of, is it going to terminate or is it going to repeat? So think about that 16. 16 can be broken down into 2 to the 4th power. Since it doesn't have another factor other than 2, I am pretty sure it is going to terminate or end. So what is a good first guess here? I know that 16 times 10 is 160. So I know it is probably not even going to be a 9. I'm going to guess an 8. I'm going to do the math. 8 times 6 is 48. Carry that 4. 128. If I added another 16 here, that would get me over the 140. I'm going to add an 8, and it's 128. And then I am going to subtract down to get 12. So I have to add another 0, bring that down. 16 times 120, well, I was at 128 with 8, so I know it's going to be 1 less than that. And then I'm going to do the math. Or you can just take this. Some people like to do the subtracting. If 16 times 8 is 128, I could subtract 16 to get 112. And then I'm going to subtract and bring down another 0. And I'm running out of space, so I'm hoping it goes, this next one is going to do it for us. And 16 times, well, we're at 112 with 7, so I'm going to guess maybe 5. And 5 times 6 is 30, and it's exactly 80. So I have a remainder of 0, and so I know that it's terminating. So this is my answer because my fraction was positive. So 3/16 is equivalent to the decimal of 0.1875 because it names the same number. All right, for these, I would like you to try using the long division to get your decimals. And remember, if it is repeating, use bar notation, which should be a review. So if you get repeating decimals, use bar notation, and I'll go over that when you are finished. So please stop the video, use your long division, and then come back. All right, let's see how you did. So I divided 3 into 1. It doesn't go in any time, so I added my point and my zeros, and right away I can see that every time I'm coming up with a remainder of 1. So I'm wondering how many times 3 goes into 10 every time, which is 3. So right away I'm getting that repeating decimal. So bar notation, you only put the bar over whatever is the repeating decimal or decimals. So in this case, 1/3 is equivalent to 0.3 repeating. If we rounded, and this is really important, if we rounded and put 1/3 is equivalent to 0.3, that is an untrue statement. They're not equivalent because this is an approximation. So we're rounding. So once you round, it's not equivalent anymore. It's approximate, which is that it's like an equal sign with a wave going through it. But you can't round and say they're equivalent because they're not anymore. So unless I ask you to round, use that bar notation. All right, and you can check the division for the rest of these. -5/6 is equivalent to negative 0.83 repeating. So there's that bar notation, so I didn't round. In this case, 8, oh, and let me point out, I knew these were going to be repeating because they had factors of 3. So 8 only has factors of 2. So remember, if you have just 2's and 5's, you know it's going to be terminating. If there's anything other than that, it's going to be repeating. So here are my answers. So make sure you finish this using long division if you've not done so already. All right, last slide. Here we have a word problem. Eric and 4 of his friends are taking a trip. They decide to split the cost of the tollway. If the toll is $8, how much will each person have to pay? So there are 5 people, and they're trying to split $8. So 5 goes into 8 one time. So all we're doing is that long division, and then I subtracted and I added a 0 and brought it down. 5 goes into 30 6 times. So since we're talking money, I'm going to put it as hundredths. So each person would have to pay $1.60. Just before leaving, 2 of his friends had an emergency. So now instead of 5 people, there's only 3 people. So we're splitting 8 into thirds. So, and I know because I'm dividing 8 by 3 that this is going to be a repeating decimal. All right, so 3 goes into 8 2 times. 2 times 3 is 6. I'm going to subtract down. I'm going to start adding my zeros. Bring that 0 down. 3 goes into 20 6 times. 18. And then I am repeating, because my remainder continues to be 2. So 2.666 repeating. So we would say each friend, and make sure that you're writing out the word, each friend, etc., would have to pay approximately $2.67. All right, so that's it for the lesson today. Can you please start your assignment and let me know if you have questions? We out.